All right, we're back at AP Review. This is 2009B, free response number 6 for the BC exam, which is a series question, because that's pretty much how the free response 6s roll, at least for the last decade or so. The function f is defined by the power series that you can see right there. 1 plus the quantity x plus 1 plus the quantity x plus 1 squared plus dot, all the way up until x plus 1 to the n, and it says n goes to infinity, so this is an infinite series, for all real numbers x for which the series converges. Part A, not a shock here, find the interval of convergence for the power series, justify your answer. So this is going to be a ratio test. Almost every time you're given a series question, one of the parts is a ratio test. So I want to do the limit as n approaches infinity of the absolute value of the a sub n plus 1th term over the a sub nth term, right? And I'm going to set that thing less than 1. But before I do that, I'm just going to go ahead and set it up, and I'm going to make the last step after I get it all set up to say that this thing is less than 1. So the nth plus 1 term would be an x plus 1 to the n plus 1, and the nth term would be an x plus 1 quantity to the n, and that's less than 1. So this is a pretty straightforward ratio test. I'm going to get the limit as n approaches infinity of, when I cancel these powers, I'm just going to get an x plus 1, no more n, is less than 1. Well, since there's not an n to plug in anymore, I don't need the n anymore, so I just get the absolute value of x plus 1 is less than 1. Now, what this really means is that the distance from -1 to x is smaller than 1. So there's a couple ways to do this. You can either, if you're good at visualizing this, what this is saying, since this is x minus a -1, right? This is centered at -1, and it's saying that you are within 1 unit from -1. So you could be up at a 0, or you could be down at a -2, right? That's one way to do it. Like, you could picture it visually. Again, this is the distance, right, from some x minus a, which is why it was a -1, and that's one way to do it, and it's totally fine. The other way to do it is to actually solve it and say that either x plus 1 is less than 1, so that's the one case. And the other case, right, so you have two cases. The stuff in the absolute value is less than 1, or the stuff in the absolute value, and then you switch the direction of the inequality sign when you do the negative case of the absolute value. So either x is less than 0, right? That's the first part. And the other part is that x is greater than -2. The reason it's an and, not an or, for those of us that don't recall back in algebra, since this is a distance that's less than something, you can picture this as a sort of house arrest versus a restraining order. The distance has to be between the two intervals instead of on the outside. The other way to think of it logically, or the other way to remember it logically, my students always remember that the great or, if it's greater, it's an or, great or. And so then this is a less than, the absolute value is less than, so it's an and. So either way, you end up getting the same 2 points I talked about, the -2 and the 0, either by doing it logically or by solving. But that's not going to be the whole answer, because they didn't say, they didn't just tell you to find the radius. This would have been the radius of convergence for just to be clear. So this is x minus a, so in this case x minus -1 is less than, my radius in this case would have been r. But they didn't ask you for that, they asked you for the interval, so that's going to involve testing the endpoints. So I'm going to get essentially 1 point. Well, there's a couple different ways to do this. You can either do it as a ratio test, which is I did. You could also recognize that this was geometric, where in this case r was x plus 1, and that would skip you right to here, and then you get to the same spot. Either way, you're getting a point essentially for getting to this section. So you're getting a point for the work to get here, and then you're getting a point for here. So 1 point for this work, 1 point for here. And then the last thing you're going to have to do is test the two endpoints. So we now know the endpoints are at -2 and 0. So what I'm going to do is I'm going to test and see what happens if I plug in -2 and 0. So I know my interval is a -2 something, right? It's either a less than, or it's a less than or equal to. Same thing here, it's either a less than or equal to. The question is, are these equal to or not, right? So what I'm going to do is I'm going to check my endpoints. The endpoints happen when x is -2, and if I plug a -2 in here, right, what's going to happen is that my a sub nth term, if I plug in a -2, is a -1 to the n, right? What that means is if I plug in a -2, here's how the series would look, right? So f of -2 would be a 1, right? Because it'd be -1 to the 0, and then a -1, and then a 1, and then a -1. And this is going to diverge. And the reason it diverges is because it never approaches a single finite number, right? If you're only here, you think that the series approaches 1, but then if you sum the first two terms, you think it approaches 0, and then you sum the first three terms, and it approaches a 1. And then the next term, and suddenly your sum is a 0. And so because this goes on forever, and it never approaches a single finite number, this diverges. And then the other endpoint, when I plug in x is 0, right, would end up with an a sub nth term that would just be a 1 to the n, right? Sorry, equals 1 to the n, which means that f of 0 would be literally infinite ones summed together, which is clearly going to diverge because that adds to an infinite value. So essentially what that means is that neither endpoint is included, and I have to have an answer that looks like this. You could either have the answer like this, or you could write the answer as parentheses -2, 0 parentheses, not brackets because it's not included. I always find it a little frustrating when neither end diverges or converges rather, because it feels like you did all that work for nothing, but you still need to make sure that you check the ends. All right, cool. I mean, the other option is that because it's geometric, you could spot that neither of them would converge because it's geometric, and in geometric series, you have to be strictly less than 1. All right, part B, the power series that we were given is the Taylor series for f about x equals -1. Find the sum of the series for f. Okay, so if they're asking you to find the sum of a series, there are only two kinds of series that we can find a sum for. One of them is geometric, which we know this is. The other one is if it's telescoping, you can find the sum because all the terms after a certain couple terms cancel. So if you're asked to find the sum, it's almost always geometric. So remember that for r values that are smaller than 1, a geometric series converges to 1 over a minus r, where a is the very first term of the series, right? So first non-zero term, right? And r is the thing that you're multiplying by every single time to get the next term. So if we look at our series, we have a 1 plus an x plus 1 plus an x plus 1 quantity squared, da 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 da. My first term is definitely 1, and then what I'm multiplying by each time is an x plus 1, right? And then I times by that r again, right? So I times by r. I should use a dot instead of an x. All right, so times by r. Cool. So once I know that this f of x is actually a over 1 minus r, right? If I clean that up a little, that's an x over, I get a 1 minus x minus 1, so I'm pretty sure I get a 1 over negative x. So that's what my series f of x converges to. Let's see. That was part B, and that's all they needed me to do. Cool. And again, that's on this window from -2 to 0. Or you can write it like this, right? Same window where it converges. All right, cool. And that's, so that's only worth 1 point because that's really just the answer, and that's it. Part C. Let g be a function defined by g of x equals the integral from -1 to x of f of x, or f of t dt rather. Find the value of g of -1/2 if it exists, or explain why g of -1/2 cannot be determined. All right, so let's go back for a sec and talk about the relationship between f and g. All right, so g of x, this is part C, is the integral from -1 to x of f of t dt. Now we established in part B that f is a 1 over a negative t because it would be f of x here, not, or f of t here, not f of x, right? So I'm integrating -1 over t dt from -1 to x, right? Well, that's a natural log, right? It's a natural log with a negative in front. So apparently g of x is the natural log, the negative natural log of the absolute value of t evaluated from -1 to x, which I'm pretty sure is the negative natural log of the absolute value of x minus a negative, so plus natural log of the absolute value of -1. Well, the natural log of 1, because that's what the natural log of the absolute value of -1 would be, is a 0. So I get that g of x is the negative natural log of the absolute value of x, which means that g of -1/2 should be the negative natural log of the absolute value of -1/2, which is a totally fine answer, right? It would end up just being a 1/2 because the absolute value. And the way the AP wrote it, and you don't have to spot this, but the way the AP wrote it was to recognize that if you bring this power up, right, that is a natural log of a 1/2 to the negative first. When you put a negative -1 power on a fraction, you flip it. So I get the natural log of 2. Any similar answer would have been fine. I would argue that the AP probably would have been fine here, or here, or here, or here. So, all right, part D. Let h be the function such that h of x equals f of x squared minus 1. Find the first 3 non-zero terms and the general term of the Taylor series for h about x equals 0, then find the value of h of 1/2. Okay, so here's the deal. We know that the f of x series, right, is 1 plus a 1 plus, or x plus 1 plus a x plus 1 quantity squared, blah, 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 right? So if we were to find h of x, right, so instead of plugging in an x, right, I'm going to plug in this whole quantity. So my h of x should be this pattern, but anywhere I see an x, I'm going to plug in x squared minus 1. So 1 plus x squared minus 1 plus a 1, right? Instead of an x, I plugged in an x squared minus 1 plus x squared minus 1 plus a 1, right? That's where the x was squared, plus da 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 da. They wanted the first three non-zero terms and the general term, right? The general term of f was an x plus 1 to the n. So this would be an x squared minus 1 plus 1 to the n, da 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 da, right? So what that means, sorry, inching that over so you can see that. So that means that h of x should just be a 1 plus the minus 1 plus 1 goes away and I get an x squared. The minus 1 plus 1 goes away and I get an x squared squared, which is next to the fourth, da 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 da. The minus 1 plus 1 goes away and I get an x squared to the n, which would be an x to the 2n, da 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 da. That's my h of x, right? Since I know what f is, right? So when I'm actually asked to find h of 1/2, remember that h of x is f of x squared minus 1, but we know what f is, right? F was a negative 1 over an x, so that would be a negative 1 over the stuff here, which means that h of 1/2 should be a negative 1 over a 1/2 squared minus 1, which is a negative 1 over 1/4 minus 1, which is 4/4, right? So that's a negative 1 over a negative 3/4. So I'm pretty sure I get 4/3. So h of 1/2 is 4/3.